Hello, everybody. It's Sunday, March 21st, the first full day of spring, and I want to welcome you again to Astronomy Online. So, yesterday was the vernal equinox. Spring began early in the morning, and it seemed only right yesterday to have a snowstorm. So I hope you weren't too bothered by that. Ours melted right away. Also today, Sunday, is the first quarter moon. And next Sunday will be a full moon, just to keep you abreast of what the situation is with the moon phases. So, welcome. And we are headed into Module 10. And with Module 10, we are leaving the solar system behind, the sun and the planets. We're going to leave those behind and start talking about the stars. And it is just so amazing that it's only in the past roughly 180, 182 years that we've been able to say anything about the stars other than to describe the constellation, the patterns that the stars make in the sky. Yet there's so much more that we now know. And how in the world did we find out all that we now know about the stars? Because all astronomers can do is look at the light that comes from these stars. So how is it that we know so much about the stars? Well, how do we know, for instance, how far away a star is? This was a great puzzle. And it was finally cracked, finally solved in the 1830s with using the method of parallax. So I want to show you, let's do a demonstration here of the method of parallax. And this is something you can do while you're watching me. So what I want you to do is to hold out your thumb, just hold out your thumb and cover up my nose. And while you're doing that, you can close an eye. Say, close your right eye. So just look at me through your left eye and have your thumb sticking out and covering my nose. Now, I'm not going to move my head. So you're just looking through your left eye and my nose is covered up by your thumb. Now, what I want you to do is to change eyes. Don't move anything, just change which eye you're looking through, and you'll find that your thumb is no longer covering up my nose. And that's because you're now looking at your thumb, which is closer to you, from a different perspective. And the shift of a nearby object against a more distant background due to a change in perspective is called parallax. And the same thing happens when Earth goes around the sun. As you look at a nearby star from one side of Earth's orbit, and then from the other side of Earth's orbit, you're viewing that star from slightly different positions. And that means that that nearby star will move relative to the distant background stars. Now, of course, you may have noticed that when you were holding your thumb over my nose and switched eyes, I didn't move my head, you didn't move your thumb, but yet there was an apparent change in the position of your thumb relative to my nose. So this only change, this isn't due to the star's actual motion in space. This parallax is just due to seeing the star from two different perspectives on either side of Earth's orbit. And this wasn't discovered until 1838. And I have an old astronomy book here. Here it is. It's an old astronomy textbook. It was published in 1839. It is an introduction to astronomy. Here it is, and this is what was used by students at Yale to learn about astronomy. And I want to show you something about this book. I'm going to open it up pretty close to the back of the book. And so this part here, this entire front part of the book, was about the solar system. It was about how the planets move. It was about our Earth. And that's it, because they didn't know anything really about the stars other than the constellations. And yes, and this wasn't even including the constellations. It said a little bit about the sun, but not too much, because they didn't know why the sun would cause the sun to shine or anything like that. Now, the rest of the book right here, this rest of the book is all there is about the stars. And in fact, a lot of that material is just about the constellations. So here's constellation, what the stars look like. And here, finally, where this bookmark is, I'll remove that. Where this bookmark is the material about the nature of the stars. And it starts right here on this page, goes to the bottom of the page, continues at the top of the next page, down to the bottom of that page, and that is it. That's all that was known about the stars back in 1839. However, the reason I really like this book is that it was published right at the cusp of the change where we began to learn something about the stars. And that's because in 1838, the parallax to a star was discovered. And by knowing how much the apparent position of that star changed, people were able to figure out the distance to that star for the first time. And in fact, in this book, there's a footnote, right? It was discovered too late to be put into the regular text, but there's a footnote in this book. And here's what that footnote says. It says that very recent intelligence informs us that Professor Bessel of Königsberg has obtained decisive evidence of an annual parallax of 61 Cygni, a star in the constellation Cygnus, amounting to 0.3136 of an arcsecond. Now that is tiny. You might remember that an arcsecond is a 60th of an arcminute, and an arcminute is a 60th of a degree. So an arcsecond is 1/3600th of a degree, and the parallax of the star was only a third of an arcsecond. And so the footnote goes on, this makes the distance of that star equal to 657,700 times 95 millions of miles. And 95 millions of miles is what they thought the distance to the sun was. So a little bit off. A distance that would take light 10.3 years to traverse. So they thought that 61 Cygni was about 10.3 light years away. It's really about 1 light year further than that, but still a pretty good number for that time. But that's the beginning. That's the beginning of our being able to figure out what these stars that we're looking at in the sky are like. And so you're going to learn about parallax and how parallax measurements are made of stars. And so how do we know about the masses of stars? Well, for that we use binary stars. And those are two stars that orbit each other, just like planets orbit the sun. These two stars orbit each other. And they're held into their orbit, just like the planets are held into their orbits, by gravity. And so if you can measure how much time it takes for those planets to go around, you can tell something about the masses of those planets. And you'll learn all about that, because that's how we weigh the stars. That's how we know how massive stars are. Also, you'll learn about other information we can get from light. Remember back in an earlier chapter, back at the beginning of the course, you learned about how each element has its own set of spectral lines in its continuous spectrum of light. You see these dark lines. And so we know what the stars are made of. We know how much of each element is in the star. We can tell the star's temperature. And so you're going to learn about how stars were classified and how that classification system enabled us to tell a star's temperature just by looking at the patterns of the light that was absorbed in the star's outer atmosphere, causing those dark absorption lines in the star's spectrum. So all of that is coming in this module. It's really an amazing tale, how we've come to almost complete ignorance about the stars 180 years ago to now knowing so much about the stars. And we have to apply the laws of nature, the laws of physics, and that means that we're going to be dealing with the mathematics of those laws. And so this is one of the more mathematical modules in the course. But please take a look at the introduction to Module 10, because there, every sort of calculation that I want you to make in the homework, I give you an example for that. And so I just want you to see how this works, how we know so much about the stars. It's absolutely a fascinating tale, and I hope you really enjoy it. Now, there's also a few things to see this time of year or in the sky. So let me go to Stellarium and show you what's in the sky right now. So I'll open up Stellarium here. Just a second. I will do that. There it is. And here's Stellarium. So we are looking out. It's about 9 o'clock tonight, and I'm looking out at the sky and facing south. This seems familiar because here's the constellation of Orion. Here's Orion with the red giant star Betelgeuse and the blue-white star Rigel. Here's Sirius, the brightest appearing star in the sky. I've repeated this several times to you, but you might notice when the course started, when we went out at night, Orion was more to the east. But since the course started, our Earth has been orbiting the sun. And so new stars are appearing in the sky at night. So slowly, as Earth orbits the sun, Orion and all of the constellations are sliding a little bit farther and farther to the west. So let's take a look over at the west. I'm just going to turn our head a little bit to southwest and look up here. Here is Aldebaran. It's another red giant in the constellation of Taurus, Taurus the bull. And here's Mars, right above Aldebaran. They're both sort of reddish, so it's a nice sight in the sky. And it's really closest probably tomorrow night. I'm sorry, I said this was tonight. This is actually tomorrow night. And you can see Mars there and Aldebaran. And the Perseverance rover has been active on Mars. It has taken a few short test drives. It has recorded the sound of it rolling over rocks, which is really sort of cool to hear. And next week, not this coming week, but the week after that, the rover has found a place to release its little helicopter. And so this little helicopter named Intrepid is going to try its first flight. And so I'll tell you more about that next week when times and days are better known. So there's a lot going on. I hope you have a great week. Please let me know if you have any questions. If you have any questions about the math that's going on, you can always drop me an email, or I'll be happy to set up a Zoom with you. But until then, have a great week, and I'll look forward to seeing you next week. So hope you enjoy learning about the stars. See you next time. Bye-bye.